presentations as they come. So let's start this journey together. So yeah, for today, I do always in my presentations, I do this like brief Polkadot introduction, but it's because I like to like set the context and explain a bit like, what Polkadot is. And in this case, I'm going to add a little bit of XEM. But the idea is to set the context so that, it's sort of like a self-contained presentation. We're going to also for sure talk about XEM. It's going to be an introduction. We're not going to do like a very, very technical dive into XEM, but it's going to be more like high level with some certain nuances and so on. Excuse me. And last but not least, we're going to do XEM on Moonbeam. What is our approach to XEM? You know that we're always focused on providing some sort of like Ethereum compatibility spin into things, and so we're going to see how we did that from the river. How is it going to be for Moonbeam? So with that in mind, let's do our 30 seconds to 1 minute introduction to what is Polkadot. And so the main Polkadot idea is a specialization in connectivity. There's no one blockchain to rule them all. So the idea is that there are many best blockchains in this space, and Moonbeam is just one of these blockchains in an ecosystem of blockchains, right? So Polkadot, it is sort of like a central hub. It is also called the relay chain or layer 0. And it's a blockchain that it specializes in connecting other blockchains and providing sort of like as a service, like security to the whole network. So there's a certain relationship between the blockchains that connect to Polkadot and Polkadot itself, where Polkadot can guarantee via its economic model that the blocks that are produced by these other blockchains can be verified and finalized by Polkadot. And so these other participants in the networks are called parachains. The term comes from parallel blockchains. And the idea is that these are these specialized blockchains that provide specific functionalities to the ecosystem. So the idea, for example, in Polkadot is that you'll have privacy parachains, storage parachains. And in that sense, you have Moonbeam, which is a smart contract parachain that provides, as you might have guessed, smart contract functionalities. And so there's a certain like very interesting thing about this arrangement is that Polkadot is nothing without the parachains, because there's no like real functionality to the end user, but there's also like the parachains themselves are nothing without Polkadot, right? So there's inherent trust that needs to be like the parachains need to have on Polkadot, because Polkadot is providing a service which is this block finalization. And on top of that service, XEM actually, it's what allows different parachains or participants of the ecosystem to communicate with each other. And so XEM, if you are already trusting, let's say in a certain way, a certain degree, the relay chain, you can also like trust the relay chain to pass certain messages or verify certain messages and so on. And XEM is sort of this feature that allows all the participants of this ecosystem to communicate with each other. And it's where we're going to like discuss today and do like a light dive into it. So I guess we can start with the XEM technical introduction. And sorry that I'm just like getting out of a cold, so I'm going to need to drink water a bit during the presentation. So like I said before, I don't consider myself like an XEM expert, but the idea is to provide, certain concepts and demo you guys how to build an XEM message and our Moonbeam approach to it. So the first thing is, what is an XEM? The important difference is that it is not a protocol, right? So XEM is not, I communicated with this. It is just the message itself. It's a format for, thanks for the water bottle. Yeah, it definitely is. It's amazing. So yeah, it is a format, it's not a protocol. And one way that I like to see it, even though this might be wrong, it is basically like, you can think about it as email, right? When we write an email, a format email for sure, is we write it with a certain format. And so basically we always have like a small introduction, let's say the Magenta blockchain wants to communicate with the Cyan blockchain. And so it's like, hey, blockchain, dear blockchain, how are you? We have not talked in a while. You have the body of the message. And then you have sort of like the outro of the message, write me back, I miss you, whatever. And then you have the firm, like, the basically the person saying, who sent the message. And so in emails, we have certain formats And the idea is that XCM, it's a format of a message that can be used for that two blockchains can talk with each other. And two blockchains and two actually consensus mechanisms as well. So you will find a lot more information and a lot more details in the bottom link that you can see at the bottom of this slide. But the idea about XCM is that it's very generic. It's not really too constrained in general. It is compatible with different fee-based systems. So you have like gas chains, you have fee-less chains or whatever. It is also compatible with systems where you don't know the transaction format, and it's meant to be highly efficient, meaning many chains, many platforms. So the idea is that it's a very performance system that it's able to generically communicate different consensus mechanisms, different blockchains. Like I said before, you can read more about it in the URL that I'm sharing at the bottom of the slide. The important thing to understand about the XCM is that XCM by itself, like I said, is just a message. And so there needs to be some sort of like XCM tech stack around the message itself. And so we're going to see this tech stack from the user to the protocol. So this is an image that I grabbed from the URL from the previous slide. And you can see here, the user would be at here of this tower. There might be a like intermediate layer called like dApps, but the user is basically here at the top, and you can see that there's certain steps that needs to be done in order for an XCM to fully fulfill this sort of like end goal, right? So basically the user will interact, everything starts with the business logic where there are these substrate palettes, which are these modules that you plug into substrate-based blockchains, or for example, smart contracts as well. And this is basically how the user interacts with the whole like tech stack. The next steps are XCM interfaces. This can be like the XCM builder palette, the contract environments, built-ins, and precompiles, and so on. So this is actually how the XCM is built. But this is not how the user interact with the XCM itself. This is what builds the XCM out of the user interaction. Then you have the XCM itself, which once again is the message that is being sent. And the next step, it's sort of like how a lot of people confuse this XCM, is that there is XCM, which is the message, and there is XCMP, which is one of the ways that the message moves from A to B. So there are the different transport protocols that it can be XCMP, VMP, bridges, custom relays. It's just a way for the XCM to move from a point to another. Last but not least, we have the consensus environments. They can be the parachains, the relay chain, the solo chains, whatever consensus environments there is, it can be added into this group. And this is where the XCM gets executed. So you have from the user to the consensus mechanism, how the whole sort of like thing works so that an XCM gets to the point where it can be executed. If you want to read more, like I said, there's this great article on the Polkadot wiki, but this is just to understand the different moving parts. And inside here, we'll do a little bit of the business logic, and we'll do a little bit deep dive a little bit into the XCMP and VMP to explain it, and we'll see some events related to it. So in terms of transport protocols, we have, like I said before, on Substrate, only VMP and XCMP is used. There is no relay, custom relays, or bridges. And so VMP stands for vertical message passing. And this is the way that the parachains, remember that the parachains are these blockchains that connect to Polkadot, the parachains communicate with the Polkadot itself. And so if Polkadot wants to send a message to the parachain, you will have a DMP. And if Mumbi wants to send a message to Polkadot, you will have an UMP, which is upward message passing, and DMP is downward message passing. So there was actually a good question in the chat that it's the meaning of XCM, and sorry that I did not said it. It has started being cross-chain messaging, but they actually changed it recently to cross-consensus messaging, because the idea is that, like Kevin said, the idea is that it can communicate different consensus and not only like different chains. So that's what XCM stands for. So in the case of XCMP, is the way that two parachains communicate with each other. And so XCMP stands for cross-chain message passing, or it could be cross-consensus message passing. I'm not even sure what is like the up-to-date term. But the idea is that the way that two parachains communicate with each other is via the XCMP transport protocol. So XCMP works by basically sending the messages directly from one parachain to the other. Okay, how this happens is that the collators, which are the block producers in the parachain environment, will put the XCM in the outgoing queue of their XCM queue. And so other collators in the other parachains will start scanning all the collators in the ecosystem to see which one has a message directed to their parachain, right? So let's say I'm a collator in Moonbeam, so I would just raise my hand saying, hey, I have a message, an XCM message for parachain 1000. And so the other collators will scan around, and when collators from parachain 1000 will see that I'm holding my hand with my message, they will just say, okay, this is for me. They will grab it, they will take it to their parachain, and they will execute it there. In this case, the relay chain only acknowledges that a message was passed by storing, I think it's like a hash of the message on the relay chain block. However, currently, the XCM, full XCM implementation is not yet ready. And so there is like a stopgap solution called HRMP, which is horizontally relay routed message passing, which the idea is that the message itself, instead of being sent from a collator to another one, it is sent from the parachain, the origin parachain, to the relay chain, which, which stores the full copy of the message on the relay chain block, and then this is then sent to the other parachain. The problem with this setup is that it's quite less performant because it is not that scalable, because when we're sending 100 messages or more, that is not as scalable in terms of the relay chain. So it is a temporary solution that it's only being implemented while the full XCM transport protocol is deployed. So I brought some examples, like high-level examples of how XCM is being used, and this is actually true right now on Kusama. And this is, for example, to transfer assets. There are two main ways right now that people are transferring assets on Kusama. One of them is via what it's called asset teleporting, and the other one is what is called remote transfers. So asset teleporting is, I like to see it as a burnt min mechanism, where in some Ethereum bridges uses this mechanism as well. But basically the idea is that when you want to move some dots, and let's say KSMs, right, from Kusama to Moon River, what happens is that these tokens will get burned, and then this is done, the token burning is done by the XCM itself. It's not like a person will just transfer the tokens to like an empty account. Oh, I burned my tokens. That is not how it works. It works, the XCM itself and execution of the XCM will burn some tokens on the origin chain, and then the destination chain will check and verify that these tokens are burned, and they will just mint new tokens to the target account. Once again, because tokens were burned on one side of the blockchain of the XCM, let's say, the newly minted tokens are like a perfect representation of that origin token. So this is like a burnt mint mechanism. This is actually being used right now on Kusama with StateMine, because they both use the same token. They both use KSM. And this requires a little bit of trust if you think about it, because let's say this parachain is malicious, right? And so all the people in the parachain vote to create 100 million dots out of the nowhere, right? So they could actually then send these dots back to Polkadot, and then that would be like an attack vector. So there's a certain degree of trust with asset teleporting. And in the case of StateMine, it's because it is a common good parachain that is not really owned by anyone. And so this will not happen on StateMine. In remote transfers, the story is a little bit different, and it's the way that this works is like these Ethereum bridges that are like block mint, burn unlock mechanisms. So they're like probably the most common bridge implementation on Ethereum and other chains is that you lock your tokens on a smart contract on one side, and then you're like some tokens are minted on the other side of the bridge. And then if you want to go back, you destroy this mint tokens, and then you get your tokens back on the origin chain. How this happens on XCM is basically that the tokens are not locked in a smart contract, but they're sent to what is called a sovereign account. And I'll explain what a sovereign account is in the next line. But the idea is that they're transferred to a special account called the sovereign account. And then what happens is that the parachain, in this case Moonbeam, this is all done, like I said, via the execution of the XCM itself. We'll check if the tokens were locked, are held in the sovereign account, and they will mint a new asset, a new representation of these tokens, and give it to the destination account. So one important difference is that these new tokens are not the same as this new blue tokens are not the same as the pink tokens. They're like a piece of paper saying, hey, these assets are held in this other account in this other chain, compared to the asset teleporting. But when you send these tokens back, what's going to happen is that you're going to get the origin tokens back, all right? And we'll see some examples in the future. So the sovereign account, what it is basically a parachain owned account in another parachain or even the relay chain. So Moonriver, for example, has a sovereign account on Kusama, and it has a sovereign account as well on Stateline. And like I said, it's an account owned by the whole parachain itself. It's not owned by one individual or by two or by three. It is held by the whole parachain. So there is no real control over this sovereign account. And so the idea of the sovereign account is that it holds some funds that are being sent. So it's like, one way that I like to see it is like the smart contracts where the tokens are locked. It's similar to that. And the address of this sovereign accounts is deterministic, right? So for example, this part of the right-hand side is the code that you can calculate the sovereign account of the parachain on the relay chain and the sovereign account of a certain parachain on other parachains. And it looks like a lot of things, but basically the main idea is that you encode the word para from parachain with the parachain ID, and you add a bunch of zeros until you get the number of bytes that it is 64 bytes. So you add all the zeros needed so that it has the correct length. In the case of the other the parachain owned account on other parachains, you encode the word sibling from SIBL from siblings with the parachain ID, and then you add the necessary zeros. What this means is that I created this tool, and you can find in this GitHub repo, where you can calculate a sovereign account address for like a specific parachain ID. So for example, for Moonbase Alpha, the sovereign account of Moonbase Alpha, which is our testnet, on the relay chain of our testnet, is this value right here. And Moonbase Alpha's sovereign account on other parachains of our testnet is this one right here. And in the case of other parachain accounts on Moonbase Alpha, what we do is that because we use Ethereum style accounts, we just truncate so that it has the same length as Ethereum addresses. So this is basically a 40 hexadecimal character, all right? So you can do this, for example, for Moonriver, if you put 2023, and then you have the sovereign accounts of the different elements here. I'm gonna drink some water. All right, so some examples, right? I guess this helps illustrate a little bit how this works. Let's say Alice on Polkadot wants to transfer some dots to Alice with the TH on Moonbeam. How would this work, right? Via an XCM, like I said, everything is done via an execution of an XCM. Alice will transfer some dots, the amount of dots that she wants to send, to Moonbeam sovereign account. And then what's going to happen is that on Moonbeam, some new assets called XE dots are going to be minted, and they're going to be transferred to Alice. Right? So it's super simple if you explain it that way. Let's say Aleph, she uses her XE dots to, send them to a friend called Charlotte, and then Charlotte wants to transfer these assets back from Moonbeam to Polkadot. Via the execution of the XEM, Charlotte is going to burn these XE dots, and then the Moonbeam sovereign account is going to acknowledge that Charlotte burned these dots, and the Moonbeam sovereign account is going to transfer the same amount of dots to Charlie, which is the account that Charlotte specified. All right. So there are little nuances here. Like, for example, there are some fees that are deducted from these dots. So if Charlotte sends 1, he's going to get like 0.99 or 0.98 or something like that. But the main idea is the same. You can imagine how this process is from a parachain to another parachain. The main difference is that the other parachain has a sovereign account on Moonbeam for this example, and the XEM execution, what happens is that Aleph transfer, for example, Glimmers to the parachain sovereign account, and then some other assets are minted in the target parachain. Going back is the same case as before, so we're not going to go through them. But this is more or less to explain at a high level how these asset transfers actually happen. All right. So more on XEM is how to open a channel, right? So before we start, super exciting to start sending assets here and there needs to be a channel that needs to be opened, right? And this is a two-step process. And so basically the idea is that XCMP channels are, and in this case it's HRMP, right? But it's what allows the parachains to actually communicate with each other. Or actually the parachain to communicate with the relay chain, but there's a nuance that I'll cover. So basically channels are one way. So if Moonbeam, for example, wants to communicate with the storage parachain, it has to open a one-way channel. But if the storage parachain wants to also communicate with Moonbeam, it has to open another one-way channel, right? So for back and forth communication, 2 channels must be open. When a parathread, so when a project connects to Polkadot as a parachain, there is already a channel with the relay chain established. That's by default. It's a 2-way channel. You don't have to open it and then get accepted or whatever. However, to open a channel from a parachain to another parachain, you actually need to do it via either governance or sudo. This is done because you have to do it via the root account. And what the root account is basically, it is in parachains that don't have sudo, which is the case for Moonroof or Moonbeam. It has to be done via governance. Or for example, in Moonbase Alpha, because it's a testnet, we do it with sudo because it's a lot more straightforward. This is to request a channel opening. And then the acceptance of the channel, so it's a 2-step process. So Moonbeam will have to say, hey, relay chain, I want to open a channel with this storage parachain. And the storage parachain has to tell the relay chain, is like, hey, I want to accept this channel opening or whatever. Right, and that has to be done as well by root, meaning that this is governance or sudo, for example. So that, the channel opening is basically done by building an XEM message. And the XEM message is actually super interesting, because it's only, the message itself contains multiple elements. And one of these elements is actually the parachain buys some execution time on the relay chain itself. So it's basically, it's like, hey, relay chain, I want to buy some execution time on the relay chain on you, so you can execute this XEM, this XEM request, which is basically open a channel, all right? And the channel you're going to open is going to be with parachain XYZ. The maximum number of messages that I want you to have in this channel is 1,000 or 8 or 10 or whatever. I'm not sure what's like the default number. And the message size, it is, let's say, 1,024 kilobytes. I think that's like the regular message size. The interesting part is that the message itself is doing multiple actions, right? It's saying, I want to buy execution. I want to execute this transaction, which is the opening of the channel. And I want to pay for the fees and everything. So it is a pretty complex message that it's being sent. the other parachain has to also build an XCM message where it buys execution on the relay chain and it says, I want to accept the channel coming from XYZ or whatever, right? So like I said, it's a two-step process. Two XCMs need to be sent to the relay chain to open this channel of communication. All right, the last step before we go to the demos is going to be, oh, there are actually two questions. Let me see them. There you go. That's a good question. I'm actually gonna, so the first one is, why do XCM transfer tokens have the XC prefix? Is there any technical reason for this, since XCKSMs and KSMs are interchangeable? That is a very good question, Vale or Bale, sorry if I'm not pronouncing it right. And you actually, we'll actually answer this in this next slide, right? Okay, the second question from Carlos, can you transfer XC assets between parachains? Example, if I mint an XC dot going from Polkadot into Moonbeam, could I transfer that XC dot into A-Star? And if so, how do you guarantee that the A-Star account will have the dots? All right, this is a really good question, Carlos, and I can answer it right now before we go to the next one. So, and then we'll go to your account, Vale or Vale, sorry. So Carlos, the thing here is that when you're gonna transfer assets, it's not as easy as I have the channel, I'm gonna start transferring assets, right? There, in the case of Moonriver, for example, because you touched the point of, well, actually you said Moonbeam, but I'm gonna use the example of Moonriver. When we started accepting KSMs, we had to register an asset on Moonriver called XCKSM, and then we had to specify, okay, this asset is linked to KSN on Kusama, right? And so what happens is that for Shiden, let's say on Kusama, to accept XCKSMs, they would have to register XCKSM as an asset on their parachain, right? And so it's a little bit more complex because that means that if we have a channel with them, we will be able to send XCKSMs to them, but they won't be able to send it back to Kusama unless they do this asset registration with Kusama. So it's a little bit more complex. I'm actually not 100% sure if all that movement is possible, but if it's possible, it is a lot of like asset registration that needs to happen all over the place, right? So because you have a channel, it doesn't mean that you can start transferring whatever token you want. There needs to be like an agreement on what token you're going to transfer, right? And they're like, that's another sort of part of the puzzle where you have to say, all right, we're gonna accept remarks, for example. Perfect. All right, when I get a message saying, hey, I'm transferring this amount of remarks, the parachain is actually charging the execution of the XCM in remark tokens, right? So I mean, that's why you send one remark and you get 0.99 or whatever. And then we have to decide, okay, what do we do with this remark token? Do we send it to the treasury? Do we burn it? Do we give it to a collator? So there are a lot of like little details that it's really hard for me to cover in like the span of 1 hour, but this is a really valid question, and hopefully at least I shed some light into, you know, the different elements that you need to consider for XCM and the channels. So that's a very, very good question. So for the other question, this is basically why I always use the XC prefix for the prefix for assets, and this is because we're always looking into this sort of like Ethereum compatibility spin or solution for everything related to Substrate, we sort of created, and I'm like air quoting myself, there's another question. I would explain to that in a bit. The XC20 assets, right? So XC20s is a term that, you know, we invented out of the blue, but it refers to Substrate XCM assets. So this is Substrate assets created with a palette, with a runtime or whatever, that have an ERC20 interface. And this is the beauty of this is basically our solution. And the beauty of it is that because it has, you can access them via an ERC20 interface, you can actually, you know, use Hardhat, Truffle, the Web3 JavaScript library, EtherJS, even MetaMask to interact with this XC20 token. Even though it's not like an ERC20 deployed on the